All right, the topic we've been talking about lately are slopes. So we're going to use slopes to deal with this, and this is called the equation of a line. All right, write that down. This is something you done in Algebra 1, but we're going to teach it again. Equation, actually just put equation of a line. Yep, and a lot of this will be familiar to you, but I'm just going to teach it just like you hadn't seen it before. Let's say you had an x and a y axis right here. Let's say you had an x and a y axis right here. And let's say you had a line like this. There's a couple things, basically two things that describe this line. Two things that we're going to talk about right now for this equation. Two things that describe this line. Okay, one thing is what we've talked about already, how slanted the line is, okay? And that is the what? How steep it is, how slanted it is. What did we just talk about? The slope, right, okay? So that's one thing that's very important about this line is the slope. All right, and we know how to find that, don't we? We could just rise over run if you know 2 points on the line, or you could put it in your little formula. Do you remember that? Do you remember we watched that Khan Academy thing? And how did he say it? He said change in y over the change in x. Remember that? The change means, like if I change from one thing to the other, you're subtracting. Remember a long time ago we talked about going to McDonald's and we said how far is it from this mile marker to the other mile marker? Remember that? How did we find the distance between those 2 mile markers? We subtracted. So the change in something is just subtracting. So y1 minus y2 over x1 minus x2. All right, so that's what we've spent a couple days on that already. All right, that's the slope. So that's pretty important about the line, but there's something else that describes this line. There's actually a couple other important points, but the equation that we're going to use today just describes one other thing, and that would be this point right here. Now, did I just pick any random point on that line? No, I picked that specific one because, Summer, what does it do? That's right, it goes through the y-axis, doesn't it? Okay, this red line right here goes through the y-axis at that particular point. We call that thing the y-intercept. Okay, intercept means is where it crosses through, and that's where it crosses through the y-axis. Here's the y-axis. This line crosses through the y-axis at that point. Because let's say the only thing I knew about this line was the slope. And you say, okay, the slope is, I don't know, let's say it's 2/5. I'm just making a number up, okay? Let's say it's 2/5. Just knowing that a slope is 2/5, does that tell you everything you need to know about where that line is located? No, because look at this line right here. Now I copied and pasted, so guess what? Guess what's true about this slope and this slope? It's the same slope, but is it the same line though? It's not the same exact line, is it? Because this line comes way down here. This line is above it and this line is below it, so it's not the same exact line, is it? So just knowing the slope is not enough to really be specific about that one particular line. I want to describe that one particular line and no other lines, all right? It's unique. This line is its own line, all right? It's one of a kind. It's unique. This line right here might have something in common with it, but it's not the same exact line. Everybody see that? So I want to be able to describe that one unique line, and I do that by two things. First thing is the slope, all right? And the second thing is the y-intercept. If I know those two things, if I know where it crosses the y-axis and I know the slope of it, then I can describe that line. But instead of just saying this, what did we say we made up the slope for that? What did I say it was? Like 2/5. Okay, so let's say the slope of that was 2/5. And then the y-intercept, I'll just shorthand it like this, y-intercept. I don't know, where do you think that is? Is it 2? Okay, positive 2. All right, instead of writing it like this, instead of writing, you know, m equals and the y-intercept equals, they have a little equation, a little formula, I guess if you want to call it, just a little way to write it so that it describes this particular line. All right, and this is how we do it. Let's do this in a yellow color. We use this equation right here, y equals, yep, mx plus b. Again, you're familiar with that, aren't you? You've seen that before. You've heard a lot about it. Some of you guys are okay with it. You're like, yeah, that wasn't that bad in Algebra 1. I was fine with that. Then some people just shake in horror from even when I say y equals mx plus b. All right, hopefully you don't feel that bad about it. But you know, if you didn't quite get it last year, hopefully we'll be able to get it this year. And I talked to Mrs. Bonsbach about it, and she said there's kids in her Algebra 2 class that are still struggling with just graphing a line and y equals mx plus b. All right. So hopefully by the time you finished Algebra 1, geometry, and then you get into Algebra 2, this stuff should be pretty solid for you. Okay, you might need a little reminder next year, but that should be all you need. All right, so you will see this again next year, I promise you. All right, so make sure that you get it now. If you didn't get it in Algebra 1, let's get it now. So let's take a look at this. Y equals mx plus b. What in the world is that? I don't even see an m here. Well, I do right there, actually. What about the b? I don't see a b anywhere. What's up with the b? Yeah, the b is the y-intercept. And you probably are wondering, why in the world did they use the letter b? Well, in other equations, if this is the y-intercept where it crosses the y-axis, what do you think this point right here would be? The x-intercept, right. Okay, now in this equation, we don't deal with the x-intercept, even though the x-intercept is still fairly important. For some reason, in this equation, we just deal with the y-intercept. All right, but the x-intercept is probably just as important, but guess what letter they use for the x-intercept? If they use B for the y-intercept, what do you think they use? Yeah, exactly. They use A for the x-intercept, all right? So that's where they get the B from. Okay, A is the x-intercept and B is the y-intercept. Does that make sense? Where they get that B from? Did anybody ever explain that to you before? Nope. All right, so anyway, they use A and B for those two intercepts, and so that's why we use B. Remember what we said about M? Why did they use M? Because it's probably from a Latin word, something about a mountain, right? So M for mountain, if you want to think of it that way. It's not exactly true, but as far as we're concerned, that helps us understand why it's in the M, okay? So this is our formula right here. But you also have an X and a Y in here, don't you? Now look, there's not only 2 points on this line, are there? There's a whole bunch of other points on this line, okay? There's a point right here. There's a point up here. There's a point all over the place. Well, this point right here can be described as an X and a Y, okay? So this X and Y represent any point. This is a very important statement I'm saying right here, okay? So let's listen to this. This X and Y right here represents any point on that line, okay? Any point. So as long as it lies on that line, so this point right here could be an X and a Y. Now, it would be a different XY than this one, wouldn't it? Okay, but any point that lies on that line, we can put the X value in for this, and we can put the Y value in for this. Does that make any sense? All right, but when we write this equation, this x will just stay an x. We're not going to replace it with a number. That's an important statement as well. Do you hear what I just said? So a lot of people get confused on this. A lot of people just want to put numbers in for everything. But this x is just going to stay an x. It's just going to stay the letter x. Professor in college it was in calculus. It was some other topic, completely different topic. But there was some formula, some equation that we did where he considered some of the letters as just window dressing. It's just there to dress it up to make it look nice and pretty, okay? So you can think of it that way. This is just window dressing. You ever hear that phrase, window dressing? Okay, like you go into the store, you go to the mall, right, and out in front, they have those windows and they put up clothes to see, you know, what's inside the store and all that kind of stuff. That's window dressing, okay, to make it look real nice and pretty. And that's what this is, basically, all right? It's the X and the Y. So that's just going to stay there. It's always just going to be X and Y. So this line right here, let's go back to this line. How would I write this? Instead of writing M equals 2/5 and the Y-intercept equals 2, how could I write that in a nice little equation like that without doing all this stuff? What could I say? Remember, the Y is just going to stay Y, isn't it? And then equals. What about the M? Do I know the M? Yeah, 2/5. So I put a 2/5 right here. Now the X just stays an X, remember? So the X and the Y just stay X and Y. And then plus, what's my Y-intercept? A 2. So there you go. So what I did, I made it nice and neat and compact. And that tells me everything I need to know about that line. It tells me the slope of the line. It tells me how it's slanted. It tells me positive or negative as well, doesn't it? So it tells me if it's going up or it's going, you know, up to the right, or if it's going down, you know, how should I say this? From left to right, if it's going up or if it's going down. That's the best way to say it. All right, and it tells me how steep it is, right? For every 2 I go up, I go what? 5 over. Do you see that? And it also tells me where it is on this graph. Is it real low right here, or is it real high, or is it somewhere in between? Well, it's at 2, right? So it crosses the y-axis at 2. That tells me everything I need to know. That is a unique line. There's no other line like this, okay? It's just that line right there. Does that make sense? So that's what that's telling you. That's what that formula is telling you. So when you see y equals mx plus b, you need to know what that stands for. So let's write it out. Y equals mx plus b. I'll put little arrows here. So m is the what? The slope of the line. And the b is the y-intercept. Okay, I'll just shorten it and put int. Is that all right? So that's the y-intercept. Again, you need to know what those things mean. The y-intercept means where that line crosses the y-axis. All right? Got a couple people need to get their heads up right here. Get her, get him. All right. All right, let's see what else we need to do. All right, let's just do an example with this, and I'll just make up something. They might ask you to graph some things, okay? So let's do this. Let's graph a line. Now, this is about as easy as it gets, okay? It doesn't get much easier than this. And you will have a problem like this on a quiz or a test, right? But this is about as simple as it gets. They'll say graph the line with a slope, and they'll probably write it out in words, okay? I'm just going to shorthand it here. They'll say graph a line with a slope of negative, let's say like 4/3, just to make us count a little bit, okay? So the slope is negative 4/3, and the y-intercept, and it crosses the y-axis at 6. All right, we'll do 6. Actually, why did I put a parentheses there? So it has a y-intercept of 6, okay? Does that make sense? So now we have to graph that thing. It's actually very easy. It's just a matter of putting a couple points, and I'm not going to use my graph paper. I'm just going to graph it like this. Should be just as good. Let's make that white. Okay. And then we'll make our line the orange. Okay. So what are we going to do first? Are we going to graph the slope first? Yeah, I don't know where the slope is. Okay. I mean, I don't know where this line is going to start, do I? So I'm not going to put the slope first. First thing I'm going to do is graph the point. And what is the point? It's right there. So the y-intercept is 6. So where do I go? I go on the y-axis, right, to 6. So 1, 2, 3, 4, 5, 6. And I put a dot right there. Pretty simple so far, right? Because it says the y-intercept. That's where it crosses the y-axis. So I'm going to put a point where it crosses the y-axis. Now I got to figure out what's my line going to look like. Is it going to? It's going to go through this point, right? Is it going to go like this? Is it going to go like this? What's it going to do? Well, let's look at the slope. The slope's going to tell us, isn't it? So the slope says it's negative 4/3. Now you could do two ways, especially if it's negative. You could go negative 4 over positive 3, or what's another way you could do it? Positive 4 over negative 3. Doesn't make any difference. I'm already way up here at 6. Do I want to go up 4? Probably not. Let's do this. Let's go down 4 and to the right 3, because remember what this is. This is rise over run, isn't it? So let's start at that point and let's go down 4. 1, 2, 3, 4. And then we're going to run positive 3. Let's put a couple lines in there. So we go down 4, 1, 2, 3, 4. And then we run, that means to the right, because it's positive, 3 places, 1, 2, 3. Put a dot right there. Now what do we do with those 2 dots? Just connect them, right? Connect the dots. You ever do that when you're a kid? Do those little booklets? You've never done that? I don't know if, yeah, I didn't know if, whoops, I didn't know if they still have that or not, but as a kid, I used to like connect the dots, right? Because they put numbers on there, right? And you go in order of the numbers and stuff, and then it makes a picture, and it makes you look like you drew a picture, and that's about as close as I ever get to drawing a real picture, because that was terrible. You've seen my artistry. It's pretty bad. All right, so anyway, connect the dots. I can deal with that, and I got my line, and there it is. There's your graph. It's as simple as that, okay? To tell you the truth, I should probably number these. So that's 6 right there. This is 3 right there. That's probably, and if you want to put the 1 and the 2 and the 1, 2, 3, 4, 5, and there you go. You got a nice line. It would really be nice if you used a straight edge somehow. If you have a ruler, or even just take a sheet of paper, just fold it in half, or take the cover to your calculator or something like that and put it up to there, so you make a nice straight line. Okay, you should get in the habit of making these nice lines. Don't just look at this and say, okay, that's it. Okay, and then have this ugly squiggly line like this. All right, it just looks ugly. Try to have a nice straight line, connect the 2 dots, and it's really going to be helpful. Now, eventually, not in here so much, but in Algebra 2, you're going to get a lot more complicated graphs in this. And you're really going to want your lines to be straight, okay, because you're going to find a point of intersection between 2 lines. I mean, you really want to be a lot more accurate. So I would really try to use a straight line. Now, to do these things, do you really need graph paper to do this? Did I really need graph paper here? Not necessarily. I didn't. Okay, so we're fine without the graph paper on this. All right. Sometimes they'll do this. Actually, let's do this. Let's copy the graph again. Sometimes they'll give you information, you have to graph it. Sometimes they'll give a graph, and you have to tell what the equation of the line is. So let's try that. Let's get this nice green right here. So let's say they give you a couple points. I'm just making this up. Let's say -1, 3, and let's say 2, -5. All right, just making those up. So let's plot these 2 points, and you want to find the equation of that line. Now there's a couple ways to do this, and we'll show you eventually a couple ways to do this. But right now, let's just graph it. Okay, so it's -1, 3, so -1, +3, right there, and then 2, -5, so 2, and then down 5. 1, 2, 3, 4, 5. So 2, -5 is right here. So let's do this, and let's do this. All right. I just want to graph it first, because eventually you're not going to have to graph it, but I want you to see what is going on here. So in order to find the equation of this line, what do we need? Well, first of all, it needs to look like this, doesn't it? Everybody see that? It needs to look like this. Yeah, I should have done something a little different, but that's okay. We'll just do it like this. So y equals mx plus b. What are we looking for? We're looking for the slope, and we're also looking for what? The y-intercept, okay? Now, this graph may be accurate, it may not be accurate, but I don't know if I want to completely trust where it crosses the y-axis. And you may be absolutely right that it does cross at 0, okay? But I want to make sure that it does. First thing I'm going to do is let's do the slope. We can find the slope. We can find the slope between 2 points, can't we? All right? You could just count if you wanted to, right? Count down and count over, or count up and count over, right? You could do that, but we just finished a whole section on slope. Let's do that with the math here. So what are we going to get? 3 minus -5, and then -1 minus 2. Let's see what we get. What's that? 8 over -3. You know what? This is going to be a little more ugly than I anticipated. I think I'm making it a little too hard for right at the beginning. Let me see what I want to do. Example 1, example 2, the slope. Yeah, let's do this. Because they usually rig these so it comes out a little bit easier, and mine's going to come out a little bit ugly. It can still work. There's nothing wrong with it, but let me just look through here. Oh, kind of got myself, painted myself into a corner right here. I've changed my mind. Let's just do this. Let's just do this, okay? We'll suck it up and see what we can get. So what do we have right now? We have the slope, don't we? So far, what do we have? Y equals what? -8/3, right? And you can put the negative on top or bottom, doesn't make any difference. And then that's an x. And what are we looking for? We're looking for what? The b, the y-intercept. That's right. So how in the world do we... Now, we could look at it, and we could guess that it's 0, but I'm not sure if it's 0 or not, because I was a little bit sloppy on writing all these points, you know. I didn't use graph paper and all that kind of stuff. So I got to find a way to figure out what b is. Now, remember what I said about this x and this y right here, this x and this y. What did I say? It's any what? It's any point on this line, isn't it? Well, do I know any points on this line? Yeah, actually, I know 2 of them, don't I? I know this point, -1, 3, and I know this point, 2, -5. So guess what? This x and y could be either this x and y or this x and y. So what I can do is I can take that x and y, put it in for these two x and y's right here, and then solve for b. Then do some math and solve for b. Which point would you rather pick? Would you rather pick this one or this one? It actually doesn't make any difference. The first one? Okay, let's do the first one. All right? Everybody with me so far? So let's see what we can do. So I'm going to do this. Y equals. So if I pick this point right here, which one is my y?
3.
It's the 3. All right, so what am I going to put in for y? 3 equals -8/3 times what?
You put a 3 instead of
I put a 1 instead of a 3. Right. -8/3 times, I was getting ahead of myself because I'm going to put what here? I'm going to put a -1 right here. And then plus what? B. Now we have to do some math and just solve for b. This was what I was thinking ahead. I was like, you know, this is going to be a little bit uglier than what you would like, but let's do it anyway. 3 equals. What's this? What's negative 8/3 times negative 1? It's positive 8/3, isn't it? Now here's the part that I was a little worried about for you guys, but I think we can deal with this. How do we get rid of this 8/3? Subtract the 8/3 from both sides. So here's the problem. 3 over 1 minus 8 over 3. But we could deal with that, and that's equal to b, isn't it? How do we subtract that? What do we have to find? Common what? Common denominator. What's the common denominator? 3. So 1 times 3, 3 times 3, which will give you what? 9 minus 8. And that equals b. What's 9 minus 8? 1/3 equals b. Now, it looked like it was 0, didn't it? But it really wasn't 0. What was it? It was 1/3. So now we can write our final equation now. Now that we've found the y-intercept, we found the slope, right? And we found the y-intercept. Now we can put it all together into our equation. So how are we going to write it? Y equals m. What's our m? Which one is it? It's negative 8/3, right? And then x. And then what's our b? Our y-intercept. We just found it right here. It's 1/3. So it's plus 1/3. Right? And that is the equation of this line right here. So what did they do? They gave you 2 points, didn't they? They gave you 2 points. This is what we do. I might have gone a little quick, but make sure you review it on the YouTube. All right? You guys with your heads down, you're not going to have any idea how to do this, and you're going to be complaining about it, and they're not listening anyway. I think he's actually snoring. How about that? Do you hear him? He is. Let's do another one. Well, get your head up then. Get your head up then. Let's do this. Here's another equation. Oh, by the way, that other one has a name. You may not know it as this name, but we're going to talk about it as this name. This has a slope, right? And it has a what? It has a slope, and it has a y what? Intercept. So we call this form right here, we call this the slope intercept form. Does that sound familiar at all? Because there's a bunch of different forms for equations of a line. This is the one that's probably most familiar to you. All right, it's the one that's, I hate to say it's most useful, but it's pretty useful. Okay, the slope intercept form. But there's another form. Okay, and the other form, I'll just write the name of it down right now. It's called the point slope form. Okay, it's the point slope form. And let me just write what the point slope form down is. Okay, you should be writing this down. So it's y minus y1 equals m times x minus x1. Now let's take a look. See what's going on here. Do you see this y1 and x1? Those are the actual points that you're going to put in. So guess what they're going to give you? They're going to give you a point and they're going to give you a slope. All right? Or you might have to figure out what the slope is. All right? But they'll give you a point, you can figure out the slope, and we're going to put it into a form that looks like this. Well, that point is the x1, y1. All right? So, and you'll know what I'm talking about here in just a second as soon as we do this. So there's the point slope form. Let's give you a point, and let's give you a slope, and let's put it into that form. So here's a point, negative 2, 5. Okay, so there's your point, and they actually give you a slope as well. Remember what I said, the other one was just about as easy as you can get with the graphing? This is about as easy as you can get with writing an equation of a line. So look what they give you. They give you a point, and they give you a slope. Now look at your formula. You see where slope is, don't you? Where is slope in this formula? What letter represents the slope in this formula? The m. So we're going to just put that negative 3/4 right in for that. Everybody see that? Now remember, the x and the y just stay x and y. But what do we put in for x1 and y1? We put this point, right? So that's your x1, that's your y1. You're just going to put those numbers in for the x1 and y1. It's pretty easy. Just plug and chug. It's pretty simple. It really is. So let's do it. So it's going to be, watch, y minus, remember this x and this y just stay x and y. So it's y minus y1. What's my y1 here? It's 5, isn't it? Equals m. What's my m? What's the slope? Negative 3/4. You just put it right there. Put a parentheses. Remember, the x just stays x. Okay? And then you put a minus. And then you got an x1. Which one's my x1? Negative 2. But we don't leave it minus and negative. What's minus and negative? Plus. And look at this. I am done.
That's all you need.
If they ask you to put it in the point slope form. Okay? So if they say, here's a point, here's a slope, write the equation in point slope form. Everybody hearing me on this? If they say write the equation in point slope form, this is how you write the equation. Okay, you don't have to write it as y equals mx plus b. But they could ask you to write it in the slope-intercept form. What's slope-intercept form? That's the y equals mx plus b, isn't it? So they could ask you to take this and put it into slope-intercept form. All right? What if they ask you to do that? Let's do the math real quick here. We're starting to run a little short on time, so let me go a little quick. Watch. Y minus 5 equals... Let's do this. What would we do to get y by itself? Distribute this 3/4 through here, wouldn't you? So it's negative 3/4 x minus, because it's negative times positive, 3/4 times 2. Yep, 3/4 times 2. Do you see that? So I just distributed this through. That's all I did right there. Let's continue. Y minus 5 equals negative 3/4 x minus, now what's this going to do right here? This 2 cancels with that, so what do we get? Minus what? 3/2. See that? 3/4 times 2 is just 3/2. Now what do I do? Add a 5 to both sides. Add a 5 to both sides. So y equals negative 3/4 x. Now we got to do a little bit of arithmetic here. Find a what? Common denominator. So that stays negative 3. What's this going to be? This is 5 over 1, isn't it? So 1 times 2, 5 times 2 is 10. What's negative 3 plus 10? 7. And that's 7 over 2. Now look at that. This equation right here and this equation right there, they represent the same exact line. But this is written in which form? This is point slope form. What slope is this? Slope what? Intercept form. So they could do that. They could ask you to put it in point slope form, which would be pretty easy if they give you a point and a slope, right? But then they could also ask you to put it into slope-intercept form, right? You might have to do a little bit of work with fractions, okay? You might have to. All right. Let's do another thing. Let's do this really quick. Let's say you had a horizontal line. Let's do it in blue. Watch, what if you had a line like this? Your line goes across like this, and you want to find the equation of that line. These are really easy. Horizontal and vertical are really easy. You just have to remember. Where does this go through? What axis does this blue line go through? It goes through which axis? The x-axis, right? Or, I'm sorry. I lied. Not the x-axis. I wrote x and I said x. But it's the y-axis. It goes through the y-axis, doesn't it? So this equation is just going to be written. When you have a horizontal line, you just write your equation y equals wherever it goes through the y-axis. Let's just say it goes through 2. Is that all right? So this equation is just y equals 2, and that's it. So a horizontal line is just y equals wherever it goes through the y-axis. So what if your line went through, like, -3, let's say? That's right. So what if that went through -3? This equation just would be y equals -3. Does that make sense? It's very, very simple. Hope you guys are paying attention. Let's look at another one. Well, we had horizontal line. What do you think is next? Vertical line. What if you had a vertical line? What do you think we're going to write that as? Now the blue lines went through the y-axis. The red line goes through what? The x-axis. So how do you think we're going to write this equation? Very good. X equals, where does it go through? Let's say 1, 2, let's say -3. All right. So this line right here would be x equals -3. What if your line went somewhere else, like right here? All right. What if your line went right here?
Please excuse
Let's
this interruption.
say
I need the
positive
following
1.
students to please come to the nurse's office.
This right here crosses the x-axis at this point right here. Okay? So, what do we call this line right here? It's going to be what? X equals +1. So, a vertical line, we'll keep this in red. Watch. A vertical line is x equals wherever it crosses through. Everybody see that? What about a horizontal line? Horizontal line, how do we write the equation of a horizontal line? It's going to be y equals what? Wherever it crosses through. So a vertical line is always x equals just a number. And a horizontal line is y equals just a number. Do you see that? These are my two horizontal lines. It's y equals 2, y equals negative 3. These are my two vertical lines, x equals negative 3 and x equals 1. All right, so if it's a vertical line, it's just x equals, horizontal line, just y equals a number, and that's it. Okay? What we're doing tomorrow, I'm not going to be here tomorrow, so you'll have a substitute in here. And what I've done is I have a worksheet for you. Listen, please. I have a worksheet for you, and it's quite a bit of work. Okay, it's a front and a back. All right, and it's on this lesson right here. So that's what you're going to be doing in class tomorrow. And so you need, listen, shh, I haven't dismissed. You need to work on that all class tomorrow. Okay, you'll have all class to work on it, but it's going to take you all class period to finish it up.